Good deal. Thanks for having me. Let's talk about Kubernetes. So I'm going to talk about Kubernetes in relation to some of the issues that we had migrating from a bare metal environment to Kubernetes and how we solved those issues, and then just some of the quirkiness of running real-time workloads in a Kubernetes environment that, where you hand your real-time workloads off to an orchestration system that can take your workloads down and spin up new ones and handling those failures and scaling. So we're going to talk about some of those things that we learned along the way, but first I'll just kind of intro myself, Joe Mordica, founder of VOXO. We are a cloud communications company, a UCaaS company, so we're like a much smaller alternative to like 8x8, Dialpad, RingCentral, so desktop apps, mobile apps, business communication, chat, video meetings, things like that. We run exclusively on open source software. We've experienced about 40% growth year over year for the past 9 years. So been really blessed. And I'll just say that we're not just an alternative to some of the bigger players. We value customer relationships as kind of our niche in the market, and we want to simplify the complicated world of telecommunications. So I'll kind of get into the slides here. This is kind of our agenda for the next few minutes. I'm going to go over our topology, which is like everything that we run in our multiple data centers and kind of how that looks visually. Talk about some of the problems that we ran into when we migrated from bare metal to Kubernetes. And then just having to deal with the mindset shift between this kind of treating your servers like pets versus cattle. And then what we did to solve some of those problems along the way, and then I'll take any questions if we have time. Maybe a little demo of us trying to take down an Asterisk or FreeSwitch node and showing you how Kubernetes replaces that node and how we don't drop any calls in the process. So you can see all the things that we're going to be talking about in our GitHub repo here, /K8. And this encompasses everything in our production environment. Everything that we run in our production environment, as far as the config goes, is all open source. So you can go here, take a picture of it. It may not be big enough, but you can at least read the URL here. And we run in 3+ data centers around the US. It's all active. There's no we can talk about that here in just a second, but 0 points of failure and 0 downtime maintenance. So we're not allowed to have any maintenance downtime. We shift our traffic between data centers and stuff like that if we need to do maintenance. And then here's a visual diagram I'll show you in just a second that encompasses kind of everything that I'm going to be talking about. So just real quick. Maybe you guys can see this. This is our GitHub repo. You can go here and kind of see all of our configs, some other presentations and slides. I actually did a ClueCon weekly with the team here. It was a really cool experience. Hopefully we'll get to do that again. And then here is the visual diagram, voxo.co/technology. This is a visual representation of our production environment, and it shows you all of the things that we're running and how we're using them. So this is kind of the meat of it here, where on the edge, we have RTP engine, Camelio, and an API, like a REST API service. So if you're a client, if you're a WebSocket client, if you're a mobile app, which is also WebSocket client, we handle push and everything, you're connecting to Camelio. And RTP engine is doing the relaying of the media between the external endpoint and internally via Asterisk and FreeSwitch. So everything inside of here, you can see my mouse kind of moving around here, is on the local network. Nothing in here is exposed to the outside. Everything up here is exposed to the outside, where in Kubernetes we have public IP addresses, and in these cases we used host network in RTP engine and Camelio. But we also have LAN interfaces on these nodes as well, so that they can communicate with the internal nodes, Asterisk, FreeSwitch, MySQL, Proxy SQL. You can see some other services that we're using here, and then here are some external services that we're using as well. We're hosted exclusively on GCP, primarily GKE. We don't have any other, there's no other like external services that we use beyond this, what you see here. Currently, we're in US Central, US East, and US South. With the click of a button or a CLI command, we can deploy in any other Google data center on GKE. And you can see how we're doing that in our config here with our up command. So this is just a bash script that basically deploys our whole infrastructure in a new data center. So again, everything that we run, operate, build is by our full-time employees, by our full-time developers, engineers, staff, and everything that we run, build, deploy, and maintain is run inside of a Kubernetes environment. That's database, that's everything. And everything is built with this idea of being ephemeral, that it can go up and down at any point in time. Just kind of getting back to the slides here. So that's kind of a visual representation of how our network is set up. Again, you can go to our website, voxo.co/technology. Feel free, I'm going to blaze through this pretty fast, so you can catch me afterwards or tonight, whenever, and ask questions. I'm going to kind of keep this high level just for the sake of time. There's a lot more meat to this, but I'll just kind of get into the basics and kind of high level. So what we're trying to do is something that, because Kubernetes is an orchestration service on top of a virtualized environment, bare metal, however you want to run it, you are allowing it to make decisions about the workloads that you're going to deploy on it. It's basically a state management. So who is familiar with Kubernetes? Okay, cool. Who is running real-time workloads in a bare metal environment? Okay, what about a virtualized environment? So hosting virtualized environment like FreeSwitch Asterisk, Camellia, RTP Engine, same hands. Okay, what about hosting in a Kubernetes environment? I saw one hand. Awesome. What about in a Kubernetes environment spanning multiple regions in a single cluster? Awesome. Good deal. So that's kind of what we're talking about here, and some of the struggles that it took for us to get from, bare metal, kind of thinking of our servers like pets, and, into a mindset shift of thinking of our servers as more like cattle. So what we're doing in a Kubernetes environment is we're managing stateful workloads globally in a very ephemeral world of Kubernetes. We're allowing Kubernetes to basically do what it does best and orchestrate our workloads. So here are some of the problems. Things are going to fail. We plan for failure in our previous bare metal environment. You just expect for the servers to stay online. You don't plan for as much failure as we probably should have. But in the world of Kubernetes, if you're allowing Kubernetes to do what it's best at, you have to plan for failure. That kind of takes a mindset shift. And then one other problem is when Kubernetes needs to take your workloads down and replace them or do a rolling restart, things like that, you're going to drop calls. But we have solutions for that to keep those nodes online until the calls are drying up. And then scaling is a problem. Like when you add more nodes, how do you discover those new services? How does your other services know about the new services that are coming online? And then how do you deal with maintenance downtime? So these are all problems that we had to face in order to go from that kind of bare metal way of thinking into the kind of ever-changing environment of Kubernetes. So let's talk about the first problem, which is the failure mindset. So like the biggest thing that we had to learn from a mindset perspective is that if we were going to host our environment fully on Kubernetes, we had to allow Kubernetes to be Kubernetes and not force it into, what I mean is like, in the bare metal world, like you kind of treat your servers like pets and not like, you have like these certain things running on certain servers and you kind of know where they are. But like in the world of Kubernetes, whether you run on bare metal or GKE or AWS's instance, it's like you have to, if you're going to dive into the world of Kubernetes, you have to allow Kubernetes to do what it does best or you're not getting the value out of it. Kubernetes, like everything, so we had to make our apps as ephemeral as possible. We had to expect them to fail and move between nodes at any time. So we don't run any like external storage or anything like that, no PVCs. We have an example here, an orchestrator example. I can provide the link afterwards. I don't know why the link didn't work there, but of running MySQL with a single primary, multiple replicas globally in a multi-region Kubernetes environment. And then the use of sidecar containers was very important for us to get our workloads in a place where they could do like graceful shutdowns and stuff like that. And then the thing that ties everything together from a service discovery perspective is Console KV by HashiCorp. So this is a global service. Who knows what Console is already? Yep. So it is. We used Console KV as like state management and service discovery. We don't use the native service discovery that Console comes with. We just use the KV because you can still set up like Console template to watch for different key values. And it's awesome. It allows us to bring up nodes or services or pods in different regions and have all of the other regions be aware of that. We also use Kubernetes. We also used GKE's multi-cluster ingress and multi-cluster services for service discovery between regions. So we can route traffic to local regions from a priority perspective. So just talking about drop calls on shutdown, we use Graceful Shutdown, where in our config files, you'll see this in our K8s repo. You'll see the way that we handle Graceful shutdowns. We use sidecar containers. So the sidecar containers are responsible for calling like Asterisk and FreeSwitch API to suspend Camellia from sending calls. So we used Camellia Dispatcher to mark the node as disabled before we want to take the Asterisk FreeSwitch server down. The sidecar container polls Asterisk FreeSwitch in order to know whether or not it has any active calls, so it can take the node down. And Dispatcher helps us out a lot there, so we can dry up Asterisk servers and stuff like that at different times. And then when the node shuts down or wants to shut down completely, the sidecar updates the global KV store, Console KV, and it takes the node down, basically shuts down all the other sidecar containers, kills Asterisk or FreeSwitch, and that node is no longer available, and it gets replaced. So when we do a rolling restart, it's one command, and that rolling restart handles our whole fleet with just that one command, dries up all the servers, updates Dispatcher where necessary, disables the node, and then as new ones come online, the same thing happens in reverse order, where the sidecar updates the global KV store, Console template, which runs on Camellia, updates the dispatcher for all the Camellia instances, and handles the bringing up of new nodes. We set a very long termination grace period seconds on our media servers, whether it's Asterisk or FreeSwitch. So I think it's something like 7 hours. So that node has 7 hours to shut down at the time and it's usually 2 or 3 hours it takes to let calls dry up and stuff like that. And then we ship our logs. Whenever the server shuts down, these may go to AWS, something like that, some kind of object store. Getting into scaling. So we introduced horizontal pod autoscalers into all of our workloads, all of our pods, our deployments, our daemon sets, our replica sets. Anything we're deploying on Kubernetes has a horizontal pod autoscaler. You'll see that on our GitHub repo as well. And you'll be able to see how we're sizing our CPU. So you'll have to tweak this and kind of understand. But basically, a horizontal pod autoscaler checks your CPU of your pod and your workload every minute or so. And if that CPU reaches a threshold, Kubernetes will add more resources. So that's exactly how our media servers work. If our media servers, which maybe 4 to 8 cores, they're smaller virtual machines, take on a certain amount of traffic, then Kubernetes, the horizontal pod autoscaler, will add 1 or 2 more media servers to our stack to start taking more calls. These could be any customer calls. We don't segment specific customers to media servers, so any of those calls can happen on any servers, basically geo-routed to the closest proximity from a latency perspective to the customer. So one thing we had to do was tweak our HPAs for scale up and scale down. So we have kind of a long burn down period where, like, at when peak hours start to kind of taper off, like towards the end of the day, we set it up so that like Asterisk and FreeSwitch servers don't go down immediately when the traffic goes down. Our burn off period is about an hour, and you can set that in the HPA to tell Kubernetes not to shave off any CPU resources until an hour or two from the time that your traffic starts to die down a bit. And then setting proper CPU requests was important for us whenever we were tweaking our HPAs. Something that we've got dialed in now. We don't want to put too many calls on our media servers. We probably allocate about the CPU enough to handle 200 or 300 calls per media server, because we don't want that big of a blast radius if something, that server has like hardware failures, stuff like that. Another thing is that the whole application lifecycle needs to be dialed in. And this means that from the time that a workload comes online to the time that it goes offline, it needs to update the global KV store, it needs to update Camellia, like it needs to update RTP. Like everything in our stack needs to be aware of things that are happening at all times, the whole life cycle of the application. And then making small iterations and testing. So I kind of, like 4 years ago, I set out on this warpath to get us from like this bare metal environment to Kubernetes. And 2 years into that, we finally migrated with 0 downtime for customers. We did the migration, and we tested and iterated for about a year after that. So we've been in production, fully production, multiple regions of Kubernetes for the last 2.5 years. Maintenance downtime. We don't allow for zero. We don't allow for any downtime maintenance. So this means that our multi-region solution is always online, whether one data center is down or up. Customers don't know. We're drying up those data centers as we're doing rolling restarts and updating Kubernetes and things like that. And one thing that we had to kind of shift our minds is to always plan for failure, right? So create the ability to delete anything anytime. So in our environment, we should be able to kill any node, any workload, any daemon set, any replica set, any deployment at any time, and the recovery should happen automatically. Using rolling restarts for resources, and then use of the Google's global load balancer. This allows us to route traffic from a latency perspective to the closest data center to the customer, which connects directly to Camellia, and then QA well. So here's a quick demo. I got 5 minutes, right? So what's that? So I'm going to pull up K9s, which is a little nice CLI tool here. And so this is one of our very low volume data centers here. You can kind of see some workloads here. This is production. This is, and I'm just going to do a rolling restart on this Asterisk deployment here. There's probably some calls on it, but it doesn't matter. So I'm going to go to deploy, hit R, do a rolling restart. And you can see that there's a new node pending right here. It says it's basically coming online. And what's happening on the back end is Google is acquiring a new virtual machine, adding it to our Kubernetes environment, and is going to deploy our workload onto that VM. So this VM is being created now. It's a little 4-core VM. And as soon as it comes online and deploys our sidecar and asterisk and stuff like that, this node is going to go into terminating status, and it's going to dry up the calls. I'll show you the sidecar where we're looping to see if, make sure there's no calls on it, before it dies. So this process takes about a minute, and it kind of comes online here. But while that's going on, I can answer some questions or anything. I knew I kind of flew through that pretty quick.
I'm going to bring you the mic, sir. Let me run this over to you. So then our live streamers can hear what you've got to say.
Very good presentation. Thank you very much.
Thanks.
Each of your clients gets their own cluster, or do you put all your clients on one cluster?
All the clients on our single multi-region cluster. Yep.
So in your product that you price to the customer, do they even know that you're on Google Cloud? They don't even know.
They don't know, no.
They just have a
VOXO
yep,
account. They log in, they connect to the closest data center, web RTC or whatever. Yep.
Thank you.
Mm-hmm.
Thank you. We can have more questions if you want. Kat,
yep.
Can you?
So while you're getting the mic over there, you can see that this node is running. It's almost healthy. And it's now running. This one is terminating now, so we can go into here. We can check our sidecar, and we can see that there's 2 active channels still. This will poll every 5 or 6 seconds. You can see that we've also disabled it from our global KV store. So now Camelio is no longer sending calls to it. It's disabled. So any queues or anything on that, it will eventually dry up because there's no more calls happening. When this goes to 0, we'll ship the logs. We'll notify all the other nodes that this server is down, this workload is down, and then Kubernetes is allowed to kill it. So this is all happening within the termination grace period seconds. Yep, and I think we got some recordings to upload too, so. But you'll see it go away in a minute. Yeah,
should we take that next question?
Yeah, go ahead. Your mic, I think.
It's already great. Hello. Oh, there we go. You mentioned on the free switch and asterisk servers, you put 300 calls per server. I'm curious how many you put in RTP engine, and if you had any problems, or what your journey was putting RTP engine in containers.
Yeah, good question. So in asterisk, just to recap, we're putting 200 or 300 calls, probably no more than that, in each one. So far with RTP engine and the kernel module, we've so far gotten away with a single RTP engine instance per data center, although they can scale out, and we can, when RTP engine hits a certain CPU usage, Kubernetes will add another one, and then the sidecar just adds it to Camelio, so Camelio is aware of it, and it can start sending it sessions. We have successfully handled 3,000 simultaneous calls using kernel mode on a 4-core VM, which is pretty impressive in kernel mode. Outside of kernel mode, it uses about 2.5 times more CPU. So we have I think some of our RTP engine config is available publicly. If not, I can share it with you, but it's basically just the entry point that configures the kernel mode, installs the kernel drivers, and inside the GKE node. So specifically, you had another question about the external and internal, like the natting, or?
We've got a question here, and then we've got a question over there as well. So let's go with you, sir.
Do you have any disaster recovery for if console goes down? Any planning for that?
Yeah, we have console set up in 3s, so it has 2 more replicas. And we replicate everything to the HashiCorp's hosted console offering. So in a case that we lose console, we can fail over to HashiCorp's hosted version. Yep.
Okay, and Kat, can you whip the mic over to this gent just here, please? He's got his hand up there. Thank you.
Thank you. Follow-up question. So have any of your clients had any kind of busy hours, like promotions, events, or things where you've spiked traffic, where you've actually exercised some of the replica set capabilities or horizontal scaling capabilities of Kubernetes? And how did that turn out?
Yeah, great question. Kubernetes handles it really well. We have power companies that have, like, trees down in natural disasters, and they have automated calling things that reach out to all their customers, and all their customers are calling in, so we have like huge influxes of traffic. It takes Kubernetes about 1 to 2 minutes to add enough capacity to handle like 3,000 or 4,000 more calls. So in that minute or 2 span, we can scale up to 3,000, 4,000 more calls, and then in the next hour, it'll start removing those compute resources as traffic goes back to normal. So truly, during the day, like, we can look at our Grafana. We use Prometheus to scrape all of our metrics, and we can see when new asterisks and our free switch servers are added and when old ones are going down, and that's usually kind of during the day. So there's new servers getting added, like in the mornings especially, and then those old ones are getting removed kind of in the evening times, and that's all happening without, with no one having to touch anything. Yeah.
Thanks, Joe. Have you got any more slides, or are we?
Nope.
Okay, in that case, if there's any more questions, you can ask Joe privately, but let's give Joe a big old round of applause right now.